Hello friends, in this video we are going to see how abstract class works in Java. The final keyword actually stops inheritance, but abstract keyword in the class name forces inheritance. We will see how when we are going through this video. A class marked with abstract keyword is called an abstract class. Per design, an abstract class may have one or more methods without body. Simply, it should have one or two abstract methods. So, like a class marked with abstract, a method can also be marked as abstract. So, once we mark a method as abstract, we no need to define a body for it. The presence of abstract keyword forces inheritance. This is because abstract class cannot be instantiated, or because an abstract class may have unimplemented method. So instantiating that class is meaningless. So simply the presence of abstract keyword in the class as well as in the method makes the class not instantiatable. So you cannot create instance out of that class. One should subclass the abstract class and implement all the methods having empty body in the base class. So, since the abstract methods are defined in the subclasses, one can create instance of a subclass. Say for example, class A, it's a base class, and class B. Class A has two methods, A1, A2. Both are declared abstract. Then class B is deriving from A, and this class B should implement both the abstract methods. So one can create instance of B. So if class B defines only one abstract method, then still class B becomes abstract. So to create instance of class B, one should implement all the abstract method defined in its superclasses. So if superclass is 1, it should so all the superclasses, in the sense, if class A and B and C are inherited in the order B is from A and C is from B, then class C should implement all the abstract methods in A and B. So if class C do that, then the user can create instance of C. Alright, this subclass should implement all the methods having empty body in the base class. So the base class can be the immediate base class, or even the base class in the inheritance tree. Below is the class shape, which is marked as abstract. So the keyword abstract is used to mark a class as abstract. The same way one can mark the method also as abstract. We will see those when we are exploring this in Eclipse. So here is our CCAR class. In this example, we are going to modify our CCAR, CBMW and 4 classes. CCAR is the base class for Ford and CBMW. Let us see how this abstract function is working. We are going to implement a pit stop service in our existing CCAR and CBMW and Ford implementation. So first we will define CCAR as abstract. You can see the usage of keyword abstract here. Public abstract class CCAR. So that's the first change we are going to make. So let's open our CCAR. If you see, this is a public class CCAR. Now we are going to change this as a public abstract class CCAR. We just added this keyword here. Next, we will define a abstract method. If you see here, we are marking this method also as abstract. when we mark a method as abstract, it should be either public or protected. Private method won't go with abstract. So I'm copying this. So let us place this after the print method. Save all. So it shows that the type C BMW must implement the inherited abstract method. So our inheritance relation already exists, so that's why the Java throws this error. So since we marked this as abstract, it expects that C BMW as well as Ford must implement this service method. So okay, let us change this as private. Now it shows a different method. The abstract method service in type C car can only set a visibility modifier, one of public or protected. So let's keep it protected here, so that this method cannot be called directly from our main method. I mean from public static void main or outside of this class. I mean the inherited class can still use this method, but from a different package, a standalone class cannot call this service method directly. So we are making it as a protected here. Then we will put one public method. So if you see call the service method, we will override the service method soon. So in the base class itself, we are making use of the undefined method, but because we know that user cannot create instance of this car object, or because it is abstract. So user cannot create instance of this car. And here I am creating a pit stop service method. So the purpose of this pit stop service is here I can do common operation that belongs to this pit stop service. Then we are making call to service method. So the service method, if you see, we don't know what specific service BMW or Ford will do. So or even some future classes, they may have a different strategy in a pit stop servicing method. So I don't know how to define it here. So what I will do, I just do operation in pit stop, the operation that is common to all the cars, that I can keep it here, or I can even keep it as a separate method and I can call that in the pit stop service. Then I will call the abstract method here service, because in C car perspective I don't know how to define this method, but derived class will tell me how they want to perform the service, in what order they want to perform the service, or what are all the action they will take on the service. So the service method is more meaningful in the derived class. So I cannot provide service method for BMW as well as Ford here, because it may vary. And in future, if they are going to create 7 more car classes, defining the service for all the 7 classes here will not be viable. So that's why we make it as a abstract, and we won't allow creating instance of car by marking it as abstract. Then we place this as an abstract method. So we are forcing the BMW and Ford to implement this service method. So when I am making a call to this service method, because of polymorphism, what happens, the call automatically goes to the overridden version of the service. So the service will be overridden in C BMW and C4. Even though this is a base class method, we will call also, once the call transfers here, the call to the service method lands up into BMW or Ford based on the instance living in the heap. Alright, so we will see that in more detail when we go to our program main entry. Now that's all with the abstract class seeker. Now we will override the service method which is expected by the pit stop service of a seeker. I mean, the service is abstract here, so that demands the inheritor should implement this method. So what we do, first we go and implement the service method in the for. So if you see, one error is gone, and here is the version of service specific to Ford. So what they do in the pit stop service, first they check the tires, then they refuel the car. After that they change the tire if required based on the check type. Then they change the driver also for the remaining laps. So this is the service method of Ford team. If let's say that this is a car which participate in the racing event, whether it is Formula or NASCAR, whatever it is. So the pit stop service strategy for Ford is defined like this. Now if you see the BMW strategy, it is different. So for a base class C car, it is not possible to guess all the service implementation at the base class itself. So the base class is useful for defining the generalization, that means a generic or common implementation. But here it is specific to Ford, and the method highlighted here is specific to Ford. So sorry, for BMW. So if we go and keep this in BMW, we will get away from this error also. So here if you see, the strategy is different. Here they are not checking the tires at all. BMW will directly change the tires, so they won't check what is the current tire condition. They change the tires to a new one. They check however the braking condition. After that they may change, they repair the brakes. After that they refuel the car. So the strategy differs between BMW and Ford. So this is the service action carried out in Ford team. This is the service action carried out by the BMW team. Now if I go to C car, you can see the service method is overridden. Here this is the abstract protected abstract void service. It is overridden here in Ford as well as BMW. So the service method is overridden here. Alright, we will create instance of these three classes in main. Once I save, you can see the error in car because cannot instantiate the type C car. Why? Because the C car is abstract, so we cannot create instance out of it. So we have to remove this entry. Now we have BMW and Ford car instance created. Next we will call our pit stop service method. So here if you see, we are calling pit stop service of BMW and the pit stop service of Ford. And if you see, that's the reason why we kept this service as protected. The protected entry, we cannot directly call service method here, but we can call pit stop service. Why? Because that is kept as public here. But this public will in turn call service method, and the service is empty here in the base class. It is meaningless when it is when the object in heap is base. Actually we cannot create base at all since we marked it as abstract. So the service will go to the overridden version of the service and it will call that. Now if you go here and put a breakpoint, we can explore how this pit stop service is called. So what I'm doing, I'm just creating the instance of BMW, then we are creating the instance of Ford. We are calling start BMW car. Now we will step inside this pit stop service method. It will go to the base class pit stop service. First it prints the performing common operation. That's common for all the cars. Then we are calling the service method. Note that here it is a base class. In the base class itself we are calling the service, and when I step inside it, we will go to BMW cars service method. So that's the beauty of a polymorphism. At runtime we decide which method to call. So now the base class car knows which version of service to call. Since the service is overridden, it will go to the derived class method. In derived class it is overridden. So this abstract service is overridden by the derived class. So when I step in, I will get into BMW service. So I perform the service operation that is specific to BMW. So when the pit stop service is called outside, so it checks the brake condition, changes the tire, then refuels it. It doesn't check tires at all. Next, we are starting the Ford car and asking for a pit stop service after running some laps. So once I step in, it goes to the service method of Ford class and it prints they are checking tires. The service operation differs if you see. Check brake condition, that's BMW, but here in Ford class we check tires, then we are refueling the car. After that we are changing the tire if required based on the check tire time. After that we change the driver for the remaining laps. So that's the pit stop service action on the Ford side. Alright. These are how abstract class is used here in our car example. So the car class, when it don't know how to implement the pit stop service method, it declared that method as abstract. So once it declares that as abstract, the class also needs to be abstract. So we kept abstract keyword in the class as well as method. Then see BMW and Ford implemented those abstract methods. Then inside the C core itself we saw that we have a method called pit stop service, and in that we are calling the service method. So in the base class itself, since we marked that service method as abstract, we are making call to that service method which is defined in C, BMW and Ford, or even in some feature classes. If some other person after some point in time defines one more class called a Ferrari, and if they provide service method, our method still works. So that's the beauty of abstraction, polymorphism, as well as method overriding. Thanks for watching. Bye.